Hello friends, welcome back to this video session on Java Programming Fundamentals. We are discussing module 2, which is Java Architecture. In this video I will introduce Java and its architecture. So let's begin with introduction to Java. So Java is a high level language which is developed by Sun Microsystem in the year 1989. Initially this language was developed for developing softwares for consumer electronics devices. It is a high-level language and a general-purpose language. The following features are provided by Java. First one is it is object-oriented, so it provides all those four features: abstraction, polymorphism, encapsulation, and inheritance. Java is simple language. If we compare this language with other object-oriented languages like C++, it is simple. The reason is there are many complex features in C++. Those are removed in Java, like operator overloading, pointers, multiple inheritance. Those complex features are removed, and some other packages are added in this language. It is robust language, very powerful language for creating any kind of applications, and it is architecture neutral. A Java code compiled on Windows can be run on Unix without recompilation. That is the most powerful feature of Java, platform independent code. So write once, run anywhere. And it is also secure because it has built-in security features like absence of pointers and confinement of Java program within its runtime environment. We'll talk about the runtime environment of Java in a while. It has support for multi-threading at language level, and it's also designed to handle distributed applications. Right. So as I told you, the most powerful feature of Java is its platform independent nature. So let us understand how Java provides this feature. So Java is a language that is platform independent. The platform is the hardware and software environment in which the application runs. Once compiled, code will run on any platform without recompiling or any kind of modification. Write once, run anywhere concept. And this is made possible by making use of Java Virtual Machine, commonly known as JVM. So what is JVM? It is a virtual machine which is used in order to execute the code. So first of all, the source code of Java will be stored in a text file with an extension .java. Then Java compiler will compile this .java file into a bytecode. That bytecode is not the machine code. It looks like a machine code, but it is not. It is an input to the JVM. And this bytecode will have an extension as .class. So when you compile a .java file, a .class file is generated, which is a bytecode. And this .class file that is generated is the machine code of this processor. Not exactly the machine code, but it looks like a machine code. The bytecode is interpreted by JVM. So once we get the bytecode, the .class file is then given to JVM, that is Java Virtual Machine, and JVM will interpret that bytecode and will give the result. So JVM varies from platform to platform, or JVM is platform dependent. So we will get a different JVM for different platform. So JVM can be considered as a processor purely implemented with the software. The interface that the JVM has to the .class file remains the same irrespective of the underlying platform. So when you get a JVM for Linux, the internal working is different, but the .class file remains the same. So JVM interprets the .class file to the machine language of the underlying platform, and underlying platform processes the commands given by JVM. So let us just see that again. So here is the source code that is written in .java. Source code. I'll name it as sample.java, and then a Java compiler is used for compiling this .java file, the source code. Compiler is used, a special compiler is used for compiling this .java file, and it generates a bytecode which is having an extension as .class. So what it generates is a machine code. Bytecode, and we'll have the extension as sample.class. So this is the first phase of compilation. Phase 1, in which only the compilation takes place. And we let's suppose we are doing this on machine 1 or processor 1, which is having a different platform. Now this bytecode I can copy or I can download from the internet, and I can give it to my JVM, and it produces the output. So here's the bytecode that is given to JVM, that is Java Virtual Machine, which internally has an interpreter in it, which will interpret that bytecode and will give the output. So remember, when we use interpreter, you don't get the file. It doesn't generate a file like a compiler does. Okay, so that is the second phase. So this can be done onto another machine. So processor P2. So which has a different platform. So write once and run anywhere. So this is how Java provides platform independability. All right, so what we have covered in this session is introduction to Java, then the features provided by Java, and the Java architecture. In the next video, we'll talk about JVM. We'll see the internal architecture of JVM. So thank you for watching. We'll see you in the next video.